Hello, I am Dr. Sharmani Mukherjee. Welcome to my YouTube channel, Let's Do Maths. Today we are going to discuss the metric space LP. What is LP? The set of all real sequences, suppose xn, such that summation mod of xn to the power p is less than infinity. That means this series is convergent. Now, let us define a metric, rather define a function d on LP as dxy equal to summation mod of xn minus yn whole to the power p summation 1 by p, where x is xn, the sequence xn in LP, and y equal to ym, a member of LP also. Now our task is to verify, number one, whether this definition of D is well defined. Next, we have to verify three conditions of metric. For two sequences x and y, we have, according to definition of LP, summation mod of xn to the power p n equal to 1 to infinity is less than infinity, and also summation mod of yn n equal to 1 to infinity is again less than infinity. That is, these two sums are finite. Now we use a well-known inequality. Now this inequality mod of a minus b whole to the power p less or equal to 2 to the power p minus 1 into mod of a to the power p plus mod of b to the power p, where a, b are real numbers, is well known. So we apply this inequality, we get mod of xn minus yn to the power p less than 2 to the power p minus 1 into mod of xn whole to the power p plus mod of yn whole to the power p. So summation mod of xn minus yn to the power p n equal to 1 to infinity is less than equal to 2 to the power p minus 1 summation mod of xn to the power p plus summation yn to the power p n equal to 1 to infinity. And using these two results, we can say that this is less than infinity. That means this sum is finite, and therefore dxy is finite and well defined. This is our step one. Let us now verify metric axioms. One thing I must mention, here p less or 1 less or equal to p less than infinity. This is the value of p. Now this is positive. Therefore, mod of xn minus yn to the power p also positive, and therefore when we consider the pth root of this summation, it should be greater than equal to 0. We get at least one positive value. Now dxy equal to 0, that means summation this series equal to 0. That means some non-negative term is 0. That means each summand is equal to 0. That is That means mod of xn minus yn equal to 0, and I should write n belongs to script n. Okay? And this means xn equal to yn for all n belongs to script n. Okay? That means, here also for all n, that means the two sequences considered first, x equal to 1, they are equal. Conversely, if we assume x equal to y, then we get each corresponding member of two sequences are equal, and then we get this line, and then the summation, and from this we get dxy equal to 0. That is, converse part follows by reversing the implication. So, dxy equal to 0 if and only if x equal to y. That is the axiom 1. From the definition of dxy, we at least say that this is equal to dyx. It is very clear, so symmetry property is true. Now, the last thing is triangle inequality. For this, we have to use Minkowski inequality. What is Minkowski inequality? Let us write this first. Minkowski's inequality says that if we have two sets of real numbers, a1, a2, an and b1, b2, bn, and p lies between 1 to infinity, then we have summation mod of ak plus bk whole to the power p whole to the power 1 by p less or equal to summation mod of k to the power p whole to the power p into summation mod of p bk to the power p whole to the power 1 by p. Now we are going to use Minkowski inequality to prove triangle inequality. For this, consider three elements x, y, z from a p where x and y and z n are three sequences. And clearly, mod of xn minus zn can be written as less or equal to summation of xn minus yn plus mod of yn minus zn. Now we apply Minkowski inequality on these two sequences. Therefore, we have summation of mod of xn minus zn to the power p whole to the power 1 by p. Actually, this is less or equal to summation mod of xn minus yn whole to the power p to the power 1 by p plus summation mod of this sequence yn minus zn whole to the power p to the power 1 by p. Okay? Summation varies from n equal to 1 to infinity. This is our Minkowski inequality. Now, this is actually dxy and this is dyz, and the left hand side is dxz, which is less or equal to dxy plus dyz, and this is our triangle inequality. So, LP is a metric space. Now, here we consider real number sequences. Instead of real number, if we consider sequences from the complex number system and proceed as follows, we get same result. So, LP may be considered as a set of all real sequences with the certain condition that the sequence may be real or complex, but the set is a metric space. Okay? If you face any problem, please tell me in the comment section. Today I should stop here. প্লিজ লাইক শেয়ার অ্যান্ড সাবস্ক্রাইব মাই ইউটিউব চ্যানেল। ধন্যবাদ।